Today, we are going to explore how to build the absolute perfect environment for high-performance AI applications on Google Cloud. Now, we're not just talking about deploying code. No. We're talking about engineering the entire arena where that code will compete and ultimately thrive. So let's dive in. In the world of AI-driven finance, this has never been more true. Every single line of code you write isn't just some command. It's a tool you forged for peak performance and precision. Think of it as your weapon in a digital coliseum where speed and intelligence decide who wins and who loses. And that right there is the key. You can have the most powerful code in the world, but it needs a battleground that can actually support its velocity, its scale, and its complexity. This is exactly why we're focusing not just on the code itself, but on the Google Cloud environment that turns that code into an absolutely formidable force. To see how this all comes together, we're going to follow a pretty clear 5-step journey. First, we'll define what makes this new arena so different. Then we'll lay its crucial foundation. From there, we'll build our modern tech stack, automate its entire life cycle, and then finally prepare it for its very first battle. So what is this new arena anyway? Well, it's a direct response to the limitations of the past. Let's be honest, the old ways of building software just can't keep up with the demands of modern AI and finance anymore. On one side, you've got the traditional monolith, basically a single massive block of code. It's slow to update, and a single failure can trigger a catastrophic collapse. And scaling, it means you have to scale everything at once, which is incredibly inefficient. But on the other side, we have the modern approach, a flexible ecosystem of smaller, independent services. This distributed design allows for lightning-fast updates, fault isolation, and really precise scaling, all things that are absolutely essential for the modern AI era. Okay, so to build these modern systems effectively, you can't just start throwing tools at the problem. You need a blueprint. You need a strategy. And that's where we introduce the foundation that underpins everything we do on GCP. So, before we pick a single service, we need a strategy. We ground our entire approach in the Google Cloudwell architected framework. Now, think of this not as a product, but as a set of proven principles for building systems that are efficient, resilient, and secure. It's basically the rulebook for our arena. This framework really stands on 5 core pillars. You've got operational excellence, that's about building systems we can actually run and monitor effectively. Security is, of course, non-negotiable. It means protecting our data from the ground up. Reliability is our promise that the system stays up and performs under pressure. And finally, cost and performance optimization ensure we're not just building something powerful, but something smart and efficient. Every single architectural decision we make has to align with these principles. All right, now that we have our principles down, let's start to assemble our arsenal. This is where we translate that framework's pillars into a concrete set of tools and services, what we call our modern application stack. So what's really interesting here is how this reveals our core strategy. First up, we package everything as containers. A container is just a standard box that bundles our code with all its dependencies so it can run consistently anywhere. Second, we run those containers on Google Kubernetes Engine, or GKE. This gives us an orchestration service that's been battle-tested by Google's own massive systems, offering reliability that's pretty much unmatched. When it comes to the actual compute, we've got 2 primary weapons in our toolkit. For the really complex applications that need to remember information, what we call stateful services, we use GKE for its powerful, fine-grained control. But for the simpler, stateless services that don't need to retain memory between requests, we lean on Cloud Run for its incredible serverless agility. It lets us run containers without even thinking about servers, and it can even scale down to 0, which is amazing for saving costs. And of course, compute is just one piece of the puzzle. Our arsenal is completed with things like globally replicated databases like AlloyDB for super high-speed, high-availability data access. We shield our applications with Google Cloud Armor to fend off massive DDoS attacks. And we get deep insight into our system's health with the integrated cloud logging and monitoring suite. It really is a complete high-performance stack. So we have the arena, and we have the arsenal. But how do we get our code, our weapon, from the developer's hands into that arena quickly, safely, and repeatedly? Well, the answer is automation. This process here is our automated assembly line, also known as a CI/CD pipeline. It kicks off the very moment a developer commits new code. That single action triggers a whole chain reaction. Cloud Build compiles, tests, and packages the code into a secure container. That container then gets stored in Artifact Registry. And finally, Cloud Deploy manages the release to production. The key takeaway here is that this entire journey from code to customer is fast, repeatable, and completely hands-free. So the most crucial point is this. We automate everything. This isn't just about speed. An automated CI/CD pipeline makes sure that every single deployment is consistent, completely reliable, and fully auditable. It minimizes the risk of human error and dramatically accelerates the whole development cycle, letting us innovate so much faster. So we've laid the foundation, we've assembled our arsenal, and we've automated the supply lines. Our developer is now fully equipped and standing at the gate, ready for the first battle. With a well-architected foundation and a powerful automated stack, we can say with total confidence, the arena is set, your arsenal is ready. We have successfully engineered the perfect environment for building and deploying high-performance AI applications. But here's the final critical question. Having all the right tools is one thing, but what happens during a moment of extreme market volatility? How do you make sure your application scales instantly and stays resilient when it's under maximum stress? That right there is the ultimate test. In our next explainer, we're going to explore the architectural patterns that act as your shield, making sure your application can withstand anything the market throws at it. So subscribe to continue the series and let's keep building.